Okay, start recording. So from previous lessons, the video quality is actually not very good. So I will need to actually explain this again. Okay, from our sampling and estimation. So okay, the 6.1 population sensor and sampling. Students are required to know what is the meaning of these three, and students need to know what does it mean by sampling frame. Sampling frame is a list. Okay, so the elements in the list is called units or elements. Okay, they are members of the population. Then what important is a sample, okay, on how to choose, okay, how to choose that actually determine whether there is a biasness or not. Okay, so the samples need to construct that the bias is avoided and identical, so that the ideally so that the sample will be written and estimate very close to the two population a parameter is estimating. So the summary of the sample, the questions here is this: is the summary of the sample is good enough to represent the population? Okay, is the what we actually are looking here. The sample looks at some of the populations. Okay, there's census. Okay, so census examining all the full population and investigation to everyone in the population. Okay, that's we call it a census. Then random sampling. Okay, random sampling, the definition here says each member of the population has an equal chance. Okay, that's the keyword of being selected, and all possible combinations are equally likely. And simple random sampling means sampling without replacement. Okay, without replacement is a keyword. Okay, in practice is usually done by using random number or some other random process. Okay, so how to actually deal with the different sampling is not actually in S2, but it may be asked in the university courses. Okay, so method of collections, as I said earlier, the way that we collect our samples may be determine the biasness. So members of collection, data can be collected automatically by electronic measurement device or in hospital or a production process or manually through a survey, questionnaire or by direct observation or recording. Okay, so this one usually actually happen a lot in social science, especially in psychology or education. Okay, let's look at example one. The population is all the students at the school. So this one, okay, 11 to 18 school. Suggest at least two different sampling frame which could use for this population. That's the list. Okay, how do you actually generate the list? So any system which lists all students in the school exactly once will be the sampling frame. So alphabetical list of all students in school, alphabetical list of students by year group, alphabetical list of students by tutor group, and etc. etc. Okay. Example 2, suggest possible population and sampling frame to investigate the following: whether a university has a gender bias in its intake procedure, okay, or where people in a town do their grocery shopping. So the method can be varies, but what you need to know is whether the practical way for us to actually generate the list. Okay, this is for the first one, whether a university has a gender bias intake. So you maybe need to take a few years of your past record to actually investigate whether selections of male and female, is there any biasness. Okay, so based on your historical data. Then B, where people in a town do grocery shopping. So this one will be slightly harder because when you do grocery shopping, you want to do survey, you actually stand in front of the shopping mall. Okay, so or the shop. When you actually stand on it, okay, you will always meet the people that actually go for grocery shopping, but they will be those people don't go for grocery shopping, they will actually stay at home. Okay, so you actually need to know how to think about it. Okay, the practical way to actually do the collection, it must be logic, and is usually this will be the real world problem. Okay, the advantage and the advantage of sampling. Okay, in some circumstances, taking survey is simply not possible or desirable. Okay, in the run up to election, opinion polls are taken to provide some information on what people think on some issues. Here, the population is everyone who could vote in the election, but the amount of time and money required to ask everyone will be far too high, and the time required to process information might mean that elections has already been taken before the analysis was available. So you have to two most important problem is time and money. Okay. Moreover, even asking everyone would not guarantee a correct prediction because people are under no obligation to respond truthfully to this sort of opinion poll, or they may be answered truthfully at the time and later change their mind and vote differently. Okay. Sampling is generally much cheaper than taking a census, and almost always a cost-effective provided a good sampling procedure are followed. Okay, if the way that you collect the data is good, then uh, it will the summary or from the sample is actually good enough to representing the population. Okay, that will be a great good news. Okay, so a high proportion of information available from a sensor can be offered to obtain a sample with cost a fraction of what the sensor would cost. In certain situations, testing item result being destroyed and the sensor is not appropriate. Okay, so I'll give you the light bulbs and the example here. When you want to investigate the lifespan of the light bulb, okay, you have 100 of them, but you actually cannot, you only have 100 of them, but you cannot use all the 100, or else you won't need you are not able to sell any of them. Okay, which is impossible. The key in sampling is to ensure that the best possible quality of information for the resources that is available, and in particular to avoid sources of the bias. There is a natural variation between the individual sampling units which is due to chance, but there are often systematic difference between groups and sampling units which one or more share characteristics, i.e. they are often different between males and female. So that will be the natural variation. Okay, so naturally male and female are basically different. Okay, so bias occur when a tendency of the sample selected to overrepresent or underrepresent a certain group is property of a sampling method. Okay, so it's a sampling problem but not the sample itself. The problem is not caused by the sample itself, okay, but it's a sampling method that actually lead to the problem. Okay, so over here, okay, you can actually all of these information are actually from your S2 book. This will be good for reading. Okay, so there are some example of biasness, okay, that we actually can look at. Subjective choice by a person taking sample. For example, a person conducting a survey in the town center may ask only people looking respectable because they are more likely to agree to participate. Self-selection, for example, radio phone-in survey are strongly biased. Only people who felt particularly strongly on the issue will be participate. One of the example that I gave you previously is the UPU survey. Okay, this is from the one of the non-profit organization that they gather information for which are the popular courses and how many students among for the Chinese in Malaysia for the government university. Okay, you can see the people that actually participate is actually passive, okay, because it's a online form. Only those students who are actually willing to, they will actually fill in the form. But you have to understand this, whoever actually fill in the form, they may be confident with their result or maybe proud of their result. For students who are actually not so proud of the result or they didn't get the courses that they want, they may not fill the survey. Okay, it can be biased in that way. Non-response. Almost all surveys have elements of self-selection in them because there is a little of the person conducting survey can do to require people to take part. The response rate of the postal survey are critical in knowing how worthwhile any information will be when the analysis is done. Company will often offer inducement entry into price draw or example to encourage people to participate. So you maybe give some small token, small gift to actually give to the whoever that participate. Convenience sampling, opportunity sampling. are chosen by which the easiest rather than any structure or systematic can be attempted to construct out the unbiased sample. Maybe I want to survey about A-levels result, okay, from the Malaysia, but I only choose the A-levels in Chempaka, which is of course is just convenient, okay. Sampling from incomplete sampling frame. For example, if you use a telephone directory or list of registered voter as a sampling frame when the population is the adult or in a community, then there will be a group of people who are seriously underrepresented because there will be people that are not in the telephone directory. Okay. Next, this will be the important part of the topic. Okay, you need to know what does it mean by sampling by this statistics. Okay, you need to know what does it mean by statistic and the sampling distribution of statistics. Okay, so let's go for method. Okay, back to S1. Okay, let's see this example. If you throw a pair of dice repeatedly and take average score on the two dice, you can generate a probability distribution of this quite easily. Okay, so we can actually get the first dice, the second die, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. You have an average of 1, 1.5, and so on. And this you actually get a average of the two dice. Okay, so with its probability. So, okay, these probability distributions of mean for n equals to 2 because of two dice. Okay, this is a statistics, okay, because x equals to x1 plus x2 over 2, because this x here, average of two dice, is a statistic because it's only rely on the function of x whatever that you observe. Okay. Then students must able to recognize a function or investigate in an investigation is a statistics or not. Okay, from here we discuss about the uh, the possible expression that to determine whether is a statistics or not. A height of 15-year-old males in a large town have a mean mu and a standard deviation of sigma. The height of the sample of 20, okay, 20 sample, 15-year-old males are recorded x1, x2 to x20. Which of the following are statistics which are not? Explain why not. So you actually see that A is a statistics, okay, because it's purely from observation. Okay, B is not a statistic because mu here is not from observation. C, this is a statistic because bar x is also come from the observation. Okay, D, the largest value is yes because it's actually observed the value. E, also you are actually from observation. F is no because of mu and sigma. G, okay, the number of value which are greater than mu. So because you're using mu as a reference, therefore it's not a statistic. Okay, H, which are greater than bar x. So this is a statistics. Okay, the day we stop up to here. Let's just continue. Okay, continue. Okay. Okay, then now what we want to see is we need to understand what does it mean by sampling distribution. Okay, next what we need to know is what does it mean by sampling distribution. Okay, find the sampling distribution. Find the sampling distributions of the mean value of the coin. Okay, so the bag contain three 50 cents, okay, two 20 cents, and 10 cents. Okay, so we can actually construct. Okay, we can actually construct in the form of lists. Okay, let's say I do it by list. Okay, so I will have the first coin, the second coin, the third coin. Okay, so two of the coin is given. Okay, only two of the coin. Okay, the first coin and the second coin. The first coin, since it's a 50, so we can have a combination of 50 with 20, 50 with 50, 50 with 50, 50 with 20, 50 with 10. Okay, we can have 20 with 50, 20 with 20. Okay, because we have two of them. Okay, then 20 with 10. So you may have 10 with 50. Okay, you can have 10 with 20, but you cannot have 10 with 10 because you only have one 10 cent. Okay, so what will be, since this will be the possible list that you have, what will be its average? Okay, what will be its average? Will be 50. So this one will be 35. This one will be 30 here. This will be 35. This will be 20. This will be 15. This will be 30. This will be 15. Okay. Then over here, what about its probability? Okay, what about its probability? From the first one, since the first coin that we draw is 50, so it will be 3 out of 1, 2, 3, 4, 6. So 3 out of 6. Then for when you take out 150, you already left of 1, so you only left with 2 over 5. Okay. Then for the first 50, you have 3 over 6, so 3 over 6 as well. Then for the second coin, for the 20 cents, you have 2 over 5. Okay, this one you have 1 over 5. And over here, for the 20, you have 2 over 6 at first, 2 over 6, 2 over 6, 2 over 6 at first. Okay. Then over here, 2 over 6, then a 50, you have a 3 over 5 here. Okay. Then the 20, you already take out 120, you only left one of them. So for when you have one of the 10 cent, so this is 1 over 6, 1 over 6. Okay, this will be 3 over 5 and 2 over 5. So if I do a simple calculation, okay, I'm not going to simplify everything. Okay, I will just multiply the number. I have 6 out of 30, 6 out of 30, I have 3 out of 30, I have a 6 out of 30, I have a 2 out of 30, I have a 2 out of 30. Okay, I have 3 out of 30. I have a 2 out of 30. So of course, if you want to check, we can actually check whether everything add up is equals to 1. If everything add up equals to 1, that means you are correct. Okay, 6 plus 6 plus 6. Okay, 18, 18, 21, 21, 25, 25, 30. So this is equals to 1. So you know that you are right. Nothing wrong here. So in the end, we construct this in the form of table. Okay, so I have the average. Okay, x here. Okay, the average x here. Let's see what other thing that we need to write. Okay, so from here, so I have a bar x. Okay, bar x. This is our sampling distribution of mean. Okay, I will have the value, the mean. I have 15, I have 20, I have 30, I have 35, and I have 50. Then this is probability value. 2 out of 30, 2 out of 30, 4 out of 30. 20, I only have 120 here, 2 out of 30. At 30 and 30 here, 3 and 3. 6 out of 30. 35. 35, 35 here, 6, 6. You have 12 out of 30. 50, you have 6 out of 30. 50, Okay, if of course you want to simplify also can. So over here you have a 2 out of 15, 1 out of 15, 3 out of 15, 6 out of 15, 3 out of 15. Okay, 6 times 3, 6 plus 3 plus 3 plus 2 plus 1, so it's 15 equals to 1. So this is correct. Okay, so this one, the final answer here, this is our sampling distributions of the mean value. Okay, then next, okay, let's go through example by example. Okay, so okay, what if I have this question? Okay, this is a similar question like example 5. How would the sampling distribution be different if there was a really large bag contain 50 cents, 20 cents, and 10 cents in the ratio of 3 to 1? That means it's not, is not, oh, sorry, wait, forgot about the, okay, again. Now, how do we actually look at this example? Okay, how about the sampling distribution? It be different if there is a really big bag of coin which has 50 cents, 20 cents, and 10 cents in the ratio of 3 to 1. Okay, over here it is a continuing from example 5. For example 5, you only have a limited coin. This one is really big. That means because it's so big that the ratio is all keep remaining the same. Okay, no different. Okay, so you always representing the ratio of 50, 20, and um, uh, 10 following the ratio of 3 to 1. Okay, so over here, then you will construct your tree diagram differently. Okay, you can actually construct a tree diagram in a different manner. Okay, so uh, again, you have the ratio of you have a ratio of 3 to 1. Okay, then we just do the calculation. This you will see that the table is exactly the same. Interesting. Okay, using the list method. Yeah. Okay, but the probability now become different. Okay, the probability now become different. So probability now, okay, because 50-50, so 1 over 2, okay, I put it in the 3 over 6 times 3 over 6. Okay, so you have 3 over 6 times 2 over 6, and this one become 3 over 6 times 1 over 6, and this one become 2 over 6 times 3 over 6, this one 2 over 6 times 2 over 6, this one 2 over 6 times 1 over 6, this one 1 over 6 times 3 over 6, and this one is 1 over 6 times 2 over 6. Okay, so here you have a 9 over 36, you have a 6 over 36, you have a 3 over 36, you have a 6 over 36, you have a 4 over 36, you have a 2 over 36, you have a 3 over 36, you have a 2 over 36. Okay, when we construct the table, okay, so let's say I rearrange the form. Because the mean value is remaining the same. It's just that the nature of the collections is being different here. So what do I get here? So for the 15, I will have 2 over 36, 2 over 36. I have a total of 4 over 36. I have 20 here. 20 is just 4 over 36. Okay, 30 here. 30 and 30. 3, 3. I have 6 over 36. Okay, 35, I have a 12 over 36. Okay, 50, I have 9 over 36. Okay, of course, you can always check whether you get it correct or not. So 12, 8, 20. Eh, why is it different? What did I calculate wrongly? Oh, okay. Well, I'm missing a case of 10 and 10 now. Okay, I'm missing a case of 10 and 10 because of this large number. So I have a 10 here. Okay, so I have a 1 over 6 times 1 over 6 equals to 1 over 36. So you'll see that, okay, because of the structure, the nature become different. So I have to add in the mean of 10 that actually give me 1 out of 36. Okay, in other words, you need to know the selections, okay, the nature itself. So this example 5 and example 6, these two comparison, okay, can actually tell you very clearly how things are actually different. Okay, both are actually calculating sample mean, but they are working differently. Okay, next let's see what are the item that we're supposed to know. Okay, next one. Okay, by using the knowledge that we learned from chapter 2, okay, by using knowledge that we learned in chapter 2, we can do some shortcut without doing all the table here. Okay, without doing all the table over here. For example, let's say from this example, okay, Control C. Okay, let's say from this example, I need to construct the mean. Okay, I need to construct the calculation, the table. Okay, table method. Then only I can actually get this number. Okay, my objective now right now is to actually find the mean value. So, mean of sample mean distribution. In other words, okay, is the expected of bar x. Okay, the bar x that we have here. So we want to find the average of this. So based on normal calculation, we will do expected of bar x over here. We will do 1 times 1 over 36 plus 1.5 times 2 over 36 plus 2 times 3 over 36 all the way until 6 times 1 over 36. Okay, let's see what is the value that we get. Okay, 1 plus 3 plus 6 plus 10 plus 15 plus 3.5 times 6 plus 20 plus 4.5 times 4 plus 15 plus 11 plus 6 divided by 36. So I have a 3.5. Okay, this one is manual way. Manual way. So how do we actually use this to actually do shortcuts? Okay, how do we actually use this to calculate shortcuts? Okay, of course, from the manual way, I already managed to get 3.5. But in order to do the manual way, I have to do a lot of things, a lot of structure here. Okay, so expected of bar x. Okay, so bar x is our x1 plus x2 over 2. Okay, expected of x1 plus x2 over 2. So I have a 1 over 2 of expected of x1 plus expected of x2. Okay, so this x1 is actually, if you remember, x1 is your fair dice. Okay, a fair dice, and we know that the fair dice is actually 3.5. So 1 over 2. Okay, 3.5 and 3.5. The answer is 3.5. Hey, you see, the answer is the same. No different. Same. Okay, that means you can actually use some sort of a calculation here that actually help us get the number, get the answer done. So, what if I want to calculate variance? Okay, variance of sample mean. Okay, variance of sample mean. So variance of sample mean, I will need to do bar x squared minus expected of bar x, the whole thing square. Okay, so over here, if we do manual calculation, let me try to key in inside calculator. Where is my calculator? Okay, let me key in inside statistic mode. Okay, variable, set up, statistic, frequency on. Okay, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. So I key in 1 over 36, 2 over 36, 3 over 36, 4 over 36, 5 over 36, 6 over 36, 5 over 36, 4 over 36, 3 over 36, 2 over 36, 1 over 36. Okay, so I key in inside a calculator, options, one variable calculator. So I will have a value of this one. Okay, three to 9 over 24 minus 7 over 2 square. Okay, so 3 to 9 over 24 divided by 3.5 square. So I have a fraction 47 over 42. Hey, why do I have a wrong number? Oh, sorry, my mistake. Mine, I go and divide. This one, press wrongly. 329 over 24 minus 3.5 square. Okay. 35 over 24. Okay, let's do the shortcut way. Variance of bar x. Okay, variance of bar x. So variance of bar x, we have variance of x1 plus x2 over 2. According to chapter 2, the multiple, we can take it out, become a square. So I have variance of x1 plus variance of x2. We totally use this from chapter 2. So 1 over 4. Variance of x1 from one dice, okay, from one dice. Try the variance of one dice, okay. So this one, this tells us the expected of x equals to 3.5. The variance of x equals to, this one will be variance of x, called discrete uniform distribution. Okay, discrete uniform distribution. What do we have here? So 35 over 12. Okay, this one I'm trying to recall from S1 formula. So I have a value 35 over 12 plus 35 over 12. Okay, I have a 35 over 4 over 24. You see, I got a correct answer. Same. That means we don't really need to go through the entire process of the creating the big table and so on, then only we can get the value. Okay, from these levels you are expected to know how to actually use the chapter 2 formulas to actually do the shortcut and get the answer. Okay, what kind of summary that we actually can get from here? Let's see. Okay, so given distribution x with mean, mu, and variance sigma square, then expected of bar x is then expected of Rx equals to mu and variance of bar x equals to sigma square over n, where bar x equals to summation of x over n. You have n samples. N samples. So relate back to the key above. Okay. A dice x with mu equals to 3.5, sigma square equals to 35 over 12, n equals to 2, bar x equals to sum of x over 2, which is x1 plus x2 over 2, variance expected of bar x equals to 3.5 immediately, and variance of bar x equals to 35 over 12 over 2, which is 35 over 24. Done. Okay, so the theory is up to here. So I'll stop recording now. I'll let you have some time to read about them.